that we have on the screen, in that picture are integrated engines, generators, water makers, VHF radios, all the equipments that you have in your boat today. The equipments can be administrated, can be operated by your cell phone directly, because those equipments are together incorporated into the NMEA backbone. You remember the procedure to connect those equipment. How much is the maximum amount of devices recommended? Yes, no more than 50. No more than 50. How much is the maximum total distance of the backbone? Depend of the cable. Remember, for mini or for micro. For mini cables, the maximum distance is 250 meters. For micro cables, 100 meters. About the drop lines, how much is the cumulative of all the drop lines together? The maximum, 78 meters, correct. And how much is the maximum distance of each drop line? Yes, it's 6 meters, no more than 6 meters. Okay, this is the source of the power. This is the object. This is an stationary observer. And the signal travels in one direction and they are bounced in the other direction. And with the formula, velocity equal distance divided by time is calculated the distance, because we know the velocity of the velocity of the sound, the velocity of the light, and you know the time. And with those elements you calculate the distance. It's very, very simple. Normally this is the part of the radar that is located on top of the flybridge, on top of the tower. Should be located in a clean area. No obstacles here, no obstacles over there, because here and here are located the sensors. Those sensors emit an infrared signal each some milliseconds, and this element is spinning. It's spinning always and sending those signals, and those signals for Doppler effect bounce and return according with the time spent in that travel. This element calculate how much is the distance. This is the effect Doppler that I explained before in the previous part of this episode. Use basically isopropylic alcohol to clean the ends of the sensors. You remember I explained the ends are plastic containers to protect the infrared sensors located inside. You need to keep that plastic with isopropylic alcohol. Never clean those terminals with acetone. Never clean those terminals with bleach. Clean those plastic terminals with isopropylic alcohol. That's the procedure. The dam in the bottom have an O-ring. Be careful with the O-ring. If the O-ring is broken, humidity enter in the system and produce erratic information and corrode the computer, corrode the feeding with the cables entering in the computer. Be careful with that. Normally, if you open that sensor, I am going, that's the picture that you have on the screen right now. You have like a gyroscope. That gyroscope should be completely free. This is the gyroscope that you have on the screen right now. Verify, move the gyroscope with your hand and verify that it's free. Okay, close again. Be careful with the seal. That's the seal that you have on the screen right now, that gasket. Be careful with the seal. Putting back the cover and verify that the sensor is in a vertical position. Follow the cable. Follow the sender in between the sensor and the computer. Follow the sender, the cable. Follow the sender and verify that the sender is not bended, it's not kicked, it's not broke, it's properly routed. Verify that sender, that cable is not close to the antenna cables, to the VHF antenna. Verify that sender is not close, is not together with AC cables. It's not close to bonding lighting conductors. Verify that that conductor is isolated from other sources of power. That's very important. It's critical for that sensor. For the same for with the radar sensor, but specific with that sensor is very critical. The radio waves that are at high frequencies carry a lot of information. Millions or billions of hertz, megahertz or gigahertz. But the inconvenience of those signals is that those signals only travel in a straight direction, in straight lines, no deflection. That's the inconvenience. For that reason, this antenna should be communicated with the satellite directly all the time, because it's a straight communication, a straight signal. This is the inconvenience of the TV signals, and the TV signals work excellent at higher frequencies, gigas or billions of trillions of hertz.